Okay, those of you who are trying to balance redox reactions, especially the simple ones, may decide that they would rather use the half-reaction method. Remember, we're not using the half-reaction method in class very much, but if you really have struggles with that one, maybe you might like the half-reaction method, so I thought I'd give you the try. It's the same sections, pages 189 through 193, exercises 12A and 12B. And the same important things to remember are that everything must be balanced in these guys. The atoms, the charge, and the electrons lost and gained. That's your job. All we're doing with this redox reaction is find a different way to balance equations. Now the stepwise function for doing this work is a little bit different. Here we separate a full reaction into two half reactions, then we balance each half reaction separately in this order. You balance the atoms for each half reaction, then you add electrons to the reactant or product side to balance the charge. Once you get everything balanced on those two ends for those two half reactions, then you multiply the entire half reaction or half reactions by a factor so that the number of electrons for each half reaction are equal, or in other words, they cancel out. Then you simply add the two half reactions together, and the results should be the balanced redox reaction. Now, what I've done is I've done the exact same three reactions that we did for the arrow method, just so you can have a good look and try to decide if these work better for you using the half reaction. I would say that these are probably a little bit simpler using the half reaction method, but you don't need to use two different methods. Use whichever one you like. We're going to do the half reaction method here. So hit pause, try the half reaction method, and remember, at some point you'll have to be able to do it without those steps. Hit pause, see if you can balance it using the steps, and then come back. Pause. Okay, you're back. So let's take a look. It's clear that the copper and the aluminum are the two half reactions. The atoms are already balanced, right? Okay. So now we're going to add electrons to each side to balance the charge. Remember, the electron is a -1 charge. If this is 0, we have to add 2 electrons here to the reactant side for that half reaction. I'm going to have to move this one over. Get ready. Give yourself some space. Al plus 3, 1 goes to 1Al. Okay. So to get this one to balance out, if we have a 0 on this side, to get 0 on this side, we're going to add 3 electrons to the reactant side. Here's a big hint. If you add electrons to the product side for the first half reaction, you're going to add them to the reactant side on the other side. Has to. Or vice versa. They can't both be added to the same side. You will have messed something up. Okay, so there we go. We've got this half reaction balanced and that half reaction balanced. There's nothing else to do. Now we have to add the two together, but whenever we do that, we have to find a way to get the electrons that you have completely able to cancel each other out. And that's going to happen by multiplying everything here by 2, multiplying everything here by 3, because the least common multiple is 6. So when we do that, what do we have? We have 3 coppers goes to 3 copper plus 2s plus 6 electrons. That's that times 3. Here, times 2, we're using 6 electrons plus 2Al plus 3, and then on the product side is 2Als. Add these two together, and what do you get? Notice that the electrons cancel across the arrow. So on the left-hand side of the arrow, we've got 3 Cus plus 2 Al plus 3s. And on the right side of the arrow, we've got 3 Cu plus 2s plus 2 Als. And we should be balanced. And we are. Check it out. You ready? Both. Ha-ha! Look at that. Exactly the same thing. 2 different ways to get the exact same answer. And you should use whichever one you feel most comfortable with. Alright? So let's try the other 2. Alright. And you can do these pretty fast, right? Split these into our half reaction. We got Fe going to Fe plus 2. We've got Cl2 going to Cl minus 1. We want to balance the atoms first. There's one of these, there's 2 of those. Then we want to add electrons to get it to balance. That means we're adding 2 electrons on this side. This is a 0, this is a minus 2, so we have to add 2 electrons to this side, right? So that's the balanced half reaction, and that's the balanced half reaction because there are 2 electrons on the product side here, 2 electrons on the reactant side here. We're multiplying by 1. In other words, 1 Fe goes to 1 Fe plus 2 plus 2 electrons added to 2 electrons plus 1 Cl2 goes to 2 Cl minus 1. Adding those together, what do you get? The electrons cancel. 1 Fe plus 1 Cl2 makes 1 Fe plus 2 plus 2 Cl minus 1. I guarantee you, in fact, we'll go ahead and look at it. Same thing, right? Same exact thing. Different way, same answer. Let's even try it with something funky, I guess a little bit funkier. This one. Same deal. Split them up into their half reactions. N2 over here goes to N minus 3. Ca goes to Ca plus 2. Those are the 2 half reactions. Let's balance the atoms first. For every one of these, there's 2 of those, right? For every one of these, there's 1 of those. That's the balance the atom step after we separate into half reactions. Now we're going to add electrons to get the charge to be the same on both sides. In this case, if this is 0, and that's minus 6, we have to add 6 electrons. Here, if this is a 0 and that's a plus 2, we have to add 2 electrons. Since there's 6 electrons that are added here, 2 electrons that are lost here, we're going to multiply this whole thing by 3, multiply this whole thing by 1, so that we end up with, adding them together, 6 electrons plus 1 N2 goes to 2 N minus 3, and then here, 3 calciums goes to 3 calcium plus 2 plus 6 electrons. Add the 2 together. 6 electrons on the left, 6 electrons on the right, cancel out. 3 Ca plus 1 N2 goes to 3 Ca plus 2 plus 2 N minus 3 minus 6 plus 6, 0, 0, 0, 0. Everything's good. And take my word for it. Same. Same. It's amazing how it works. Now, one of the things that's really important to recognize here, and let's do it with this pair right here. Notice that the copper side was the one that gave up 2 electrons. It lost 2 electrons. The aluminum side was the side that gained the electrons, and it gained a total of 6. And the copper side lost a total of 6. So we're really doing the exact same thing, just in different ways. The arrows are essentially the half reactions. It's the same kind of problem. You just have to do it in whichever way you feel most comfortable. I think these are equally comfortable using arrow method or half reaction for these simple problems. When we start to do the more complicated problems, that's where I think the arrow method gets better. It's up to you to decide whichever works well so that you can quickly go through and get the problems right. Practice up. Good luck.